Hi, I'm Nathan with Holston Gases. During this training module, we're going to discuss the shielded metal arc welding process, otherwise known as stick welding. We're going to discuss setting up a stick machine or a welding machine for stick welding, the equipment necessary, electrode classification, how to identify the different electrodes and their uses, and a little bit about the stick welding process. Now, the stick welding process is an arc welding process with an arc between a covered electrode and a weld pool. It uses a disposable electrode that has a flux coating around it. As the weld is made, the flux coating burns off to provide the shielding, the flux, and the chemistry for the weld joint. The electrode, or the center portion of the electrode, provides the filler metal that fills up the joint. Now, the stick welding process is not typically used in high production facilities. However, we will find the stick process in plant maintenance areas, plant shutdowns, pipeline welding, repair shops, field construction, farm equipment, hard to reach weld joints, areas or weld joints where it's not feasible to use shielding gas with there may be a lot of wind, and also it's used quite a bit with the homeowners. Now we're going to start discussing the power source and equipment necessary for stick welding. The power source is very simple, however it's very important that when selecting a power source that the power source is constant current or designates stick welding. On this Bobcat 250, which is our example today, we can see that it has a selection for stick welding, so we know we have the correct power source. It is also AC/DC. When stick welding, you can use AC current or direct current, electrode positive or electrode negative. Now, there are a few pieces of auxiliary equipment that are required for stick welding. The first is the electrode holder. The electrode holder is what actually holds the electrode and what the operator holds in his hand to manipulate the electrode down the joint. Now, this is also referred to as a stinger or a dog. Next is the work clamp. The work clamp is actually what hooks onto the piece of work that the operator is welding on. Now, the work clamp is sometimes referred to as the ground clamp, but the correct term is work clamp. Now, the work clamp and the electrode holder are amperage specific, so it's important not to undersize these two pieces of equipment, otherwise they will become overheated. So as an example, if the operator is welding at 300 amps, then he needs to have an electrode holder that's capable of welding at 300 amps along with the ground clamp. Otherwise, they will overheat and prematurely fail. The next piece of equipment that's often undersized and overlooked is the welding lead. The welding lead is actually what carries the welding current from the power source to the welding arc. So there's two variables that must be known to size the welding cable appropriately. The first variable is the welding amperage. So as an example, if we're welding at 200 amps, we'll remember that. And then the next is the length of the circuit. So to determine the total welding circuit length, we need to know how far we will be welding from the power source, or how much welding lead the operator plans to have hooked up to his power source. So as an example, if he's welding 100 feet from the power source, that means he's going to have 100 feet of stinger lead and 100 feet of work clamp lead for a combined welding circuit of 200 feet. Then we can use the charts that are provided for us in the owner's manual of the power source. So for example, if we're welding at 200 amps at 200 feet away from the power source with 200 feet of lead, we can look at our chart and we'll find out that the required cable size is 1/0. So I highly recommend that you use these charts when sizing welding cable, otherwise the welding cable could prematurely fail from overheating. There are really two main ways to hook up the welding lead to the power source output studs. The first is what I like the most is a quick connection. It's known as an LC40, and it just simply twists and disconnects and then is inserted and twists and is installed. And then next is a copper lug. This copper lug crimps on to the welding cable, and this is more of a permanent connection. And it's important to make sure that these connections are very tight so that you don't build up any resistive heat at the connection points. So now that we've talked about the welding equipment and how to set up the welding equipment and a little bit about the auxiliary equipment, Now we can start discussing the electrodes and the electrode classifications. So below we have the electrodes that are used for stick welding. Now these are referred to as electrodes as a proper term, but a lot of time they are called a stick or a rod. The correct term is electrode because current passes through it. Now there are many different types of electrodes. They all have solid metal cores, and all electrodes used for stick welding have a baked on flux coating. And the flux coating will determine the properties and the arc characteristics of the welding arc when stick welding. Now the electrode, the core, conducts the current, and when it melts, it's deposited as weld metal. And the flux burns off while welding and provides the atmospheric shielding. It directs and stabilizes the arc. It provides the slag, deoxidizers, and scavengers for the welding arc, and also adds elements that affect the deposited weld chemistry. Now, as you see here, there are different numbers on both of these electrodes. These numbers designate different properties of each of these electrodes. So now we can discuss the electrode classification. We'll start with the 7018 H4R. The 70 represents the as-welded tensile strength of the deposited weld bead. So that means that the deposited weld bead with the 7018-H4R will be 70,000 pounds per square inch. The 1 represents the position that the electrode can be used to weld in. So as an example, 7018 has a 1. We can use that all position. So a 1 represents all position, meaning that we can weld in the flat, the horizontal, the vertical, and overhead position. If it were a 7024, that would tell us that we could only weld in position, which means we could only weld in the flat or the horizontal positions. The 8 represents the type of flux coating and also the type of welding current that can be used with this electrode, whether it's AC, DC electrode positive, or DC electrode negative. The H4R represents the hydrogen content of the electrode. Now the 6010 electrode tells us that the deposited weld bead has a 60,000 pounds per square inch tensile strength. It also has a 1, so that tells us that it can be used all position, and it has a 0 as the type of coating and current. I like to refer to the Hobart manual to determine which current and what type of coating it is. I highly recommend, whenever speccing out an electrode, to refer to the electrode's data sheet to find this information. You'll find a link here below on the screen. So a lot of the information that we've talked about that's found on the classification number of the electrode can also be found on the package of the box of electrodes. So as you can see here, here's the AWS classification for this box electrodes. It's E6013. The E tells us that it's an electrode. The 60 tells us that it's 60,000 pounds tensile strength. The 1 tells us that it's all position, and the 3 tells us the coating and the current to use with this electrode. Also, we'll find out right here is the lot number, the diameter of the electrode, the amperage range this electrode can be used in, and also the current to weld in. So this one can be used for AC, DC electrode negative, or DC electrode positive. So there's a lot of information that can be pulled right off the label of the package of electrodes. So keep this in mind too as you're looking for electrodes for your customer. So the final topic to cover is how to set the welding machine for the appropriate welding current that you'll be welding at. If you're not able to get to the manufacturer's data sheet, then a good rule of thumb for a starting current is to take the diameter of the electrode, convert it into a decimal, and multiply it by 1,000. So for example, if you're using an 1/8 inch electrode, 1/8 inch as a decimal is 0.125 multiplied by 1,000 will be 125. So that's a good starting point for the welding current. Now that may not be where you want to weld based on the welding conditions and the position you're welding, but that's a good starting point. So to set it for 125 amps, what I'm going to do is I'm going to make sure that I'm an electrode positive stick, and I am. Next, I'm going to choose an amperage range. So really, if I'm going to be welding at 125 amps, I can use this range, this range, this range, or this range. So I want to be in the middle of my amperage range. So I'm going to select between 60 and 160 amps. This is your course adjustment. Now to fine tune that, since 125 amps is pretty close to the middle of this range, I'm going to leave my amperage dial right here in the middle, and that's going to be about 125 amps. Now if we wanted to, we could also set it here and then turn this dial up so that it would be closer to the maximum of this course range. So this is how that works. So this is the course range setting of 40 to 130 amps. This is the fine adjustment of that range, 10 being all the way at 130 and 1 being down at 40. Same is true at this range. With the fine amperage at 1, that should be about 60 amps output. As I turn it up, it'll increase to about 160 amps output. Now the advantage of this machine is it tells us which amperage range I can use at each course selection. So here and here it says that the recommended rod or electrode is 3/32 to 1/8 inch, 1/8 inch to 5/32, and this one says that you can use 5/32 and up to 3/16 inch electrode over here. So that's a quick explanation of how to set your power source for the welding amperage, and a quick rule of thumb for selecting the right amperage for the electrode you've used. That concludes this training module on the stick welding process, otherwise known as shielded metal arc welding. I hope you have found this information valuable and helpful, and thank you for watching.